Okay, now let us look at example 2 of our lecture notes. So in our example 2, let me bring up my pen. Let us look at what is happening. We are given that a source of light in which we know that this source of light is actually emitting light of wavelength 550 nanometers at a power, that is an important information, of 1.25 watts. We are asked to calculate how many photons are emitted in 1 second. So the first thing we have to do is try and relate the power to this number of photons. Now we know that light itself, when it emits light, okay, it is actually emitting photons, okay, the energy packets, alright, and each photon itself carries an energy of HF. So in fact, we can express the power, which is the energy per unit time that's emitted by the light, in terms of the number of photons, okay, let me write that down, multiplied by the energy of one photon. But we need to divide by time, so that would be the energy per unit time, which is equivalent to the power. I'm going to put this in symbols so it's easier to solve. So I'm going to let P be the power, the number of photons, alright, per unit time to be N over T, and we know that the energy of photon, let it be E, which is E is equal to HF. So if I write this in an equation, we can have P equals to N over T times HF, and all we have to do now is rearrange this equation to get our number of photons per unit time, and so rewriting, we will have it to be P over HF. But in this question, we are not given the frequency, so we're going to convert the frequency of the photon. Since photon is equals to a light particle, so we can write F to be the speed of light divided by the wavelength. So written in that way will be actually P lambda over HC. So we've got everything here. We've got the power, we've got the wavelength, we've got Planck's constant, and we know the speed of light. We would be able to get the answer. So substituting in, I'll have 1.25 watts. Lambda in the question is given in nanometers, so what we need to do is we must remember to convert to meters, alright, and Planck's constant we know is 6.63 times 10 to the power of minus 34, and speed of light from our list of constant is 3 times 10 to the power of 8. And what we can do is put this through the calculator, and you should be able to get the answer, which is 3.46 times 10 to the power of 18 in 1 second. So per second. Okay, done.